Let's look at solving rational inequalities. For example, let's solve this inequality for x. Now, if this were an equality instead, we would cross multiply. However, we cannot do that here because we do not know x, and hence we don't know whether these expressions are positive or negative. And remember, when you multiply both sides of an inequality by a negative number, that inequality sign will flip. So since we do not know whether we're multiplying by a negative number, we cannot do that. So instead, we rewrite this inequality by getting 0 on the right-hand side. That is x plus 1 divided by x minus 6 minus x plus 2 divided by x minus 4 is greater than or equal to 0. And now we'll find a common denominator on the left-hand side and simplify. And the common denominator is the product. So what we get is x plus 1 times x minus 4, and then minus x plus 2 times x minus 6, all divided by this product, x minus 6 times x minus 4. And now let's FOIL the two expressions in the numerator, which gives us x squared minus 4x plus x minus 4, and then minus, be careful, it's minus the quantity, x squared minus 6x plus 2x minus 12. Still divided by x minus 6 times x plus 4. And now distributing the negative gives us x squared minus 4x plus x minus 4 minus x squared plus 6x minus 2x plus 12. And now combining like terms in the numerator, the x squareds will cancel. And combining all the x terms gives us negative 4x plus x is negative 3x, and then plus 6x is positive 3x, and then minus 2x is positive x. And the numbers combine to give us negative 4 plus 12, which is 8. Now let's let f of x equal the left-hand side here. So we want to find x values for which f of x is greater than or equal to 0. And isn't f a rational function? So we'll use the fact that a rational function without any common factors in its numerator or denominator can only change signs at the zeros of its numerator or the zeros of its denominator. That is, at its x-intercepts or on either side of its vertical asymptotes. So looking up here, the zeros of the numerator are x is equal to negative 8. And the zeros of the denominator are x equal to 6 or 4. Now these three values partition the real number line into 4 intervals. So let's say this is negative 8, and this is 4, and this is 6. So what we'll do is choose a representative from each of these intervals and determine whether f is positive or negative within each interval. And then we'll choose the intervals on which f is positive. All right, let's start with the first interval. We can choose x equal to -9, for example. And if we plug -9 into this factored form of f up here, we have -9 plus 8, which is a negative number, divided by -9 minus 6, which is a negative number, times -9 minus 4, which is also a negative number. And negative divided by negative times negative is negative. Which means in this first interval here, f is negative. All right, and what about in the second interval? We can choose x equal to 0, for example, and plugging that into this factored form of f up here, we have 0 plus 8, which is a positive number, divided by 0 minus 6, which is a negative number, times 0 minus 4, which is also a negative number. And positive divided by negative times negative will be a positive number. Which means in this second interval here, f is positive. All right, and then in the third interval, we can choose x equal to 5, for example. And plugging 5 into this factored form of f up here, we have 5 plus 8, which is a positive number, divided by 5 minus 6, which is a negative number, times 5 minus 4, which is a positive number. And positive divided by negative times positive is negative. Which means in this third interval, f is negative. All right, and what about the last interval? We can choose x equal to 7, for example. And plugging 7 into this factored form of f, we have 7 plus 8, which is a positive number, divided by 7 minus 6, which is also a positive number, times 7 minus 4, which is also positive. And positive divided by positive times positive is positive. Which means in this last interval here, f is positive. Now remember, we're looking to find the x values for which f of x is greater than or equal to 0. And we just found that f is positive in this interval and in this interval. However, looking here on the right, we also have this condition of equality here, which means we need to include in our solution the x values for which f is equal to 0. But be careful here. Look at this expression f. F is only equal to 0 when the numerator is 0. And for those x values, the denominator is not. So that means we need to include this x is equal to -8 here on the graph in our solution. We do not include 6 or 4, only -8. That means our answer then, written in interval notation, is close bracket at -8 because we want to include -8, up to 4, open parenthesis at 4 because we do not want to include 4, union, again, open parenthesis at 6 because we don't want to include 6, up to infinity. And this is an example of how we solve a rational inequality. Thank you, and we'll see you next time.